Hello and welcome. My name is Mark DeWeese and I'm a medical physicist from the United States. I'm here in Germany today at the IBA Academy at the International Competence Center. We will be introducing people to TPS commissioning and efficient beam scanning over the next couple of days. You'll be seeing some of the tools that IBA offers and some of the techniques that are considered standard for accurate, efficient, and organized data collection in the process of going from a linear accelerator to a treatment planning system. We will be covering software in the preparation for this project. We will be covering hardware, cable connections, setup techniques, and we will be covering software on the post data collection for data processing and etc. The project of doing beam commissioning or performing beam commissioning and TPS commissioning is complicated and arduous. Any techniques that can be employed to maintain organization and efficient data collection are of great value. We hope to convey some of the tools that IBA makes available through software and hardware to the medical physics community and how to best leverage those tools to accomplish this goal in an organized, efficient, and accurate manner. The rails set on the acrylic tank body, their heights are adjusted by these 4 pins here. You basically just want to make sure that you have a roughly halfway point so that if you need to adjust up or down, you can do that afterward. So what we have here are the starting components. These are all the things that we're going to attach to the scanning tank to set the whole system up in preparation for data collection. We have the communication and power cable that goes from the CCU to the tank body. It allows power to the rails. It allows communication back to the CCU of coordinates, locations, etc. We have our 2 triaxial cables, excuse me, for communicating signal from the detectors back to the CCU. We have the CCU here. Our 2 detectors, in this case they're ion chambers, CC13. This is what we're going to start with, our 2 for a reference detector and a field detector. Power cable for the CCU and a standard Cat5 Ethernet cable to facilitate communication from the CCU out to the software. The cables are labeled. This has an R on it for reference. And that's just so you can keep track of which cable goes with which point. You got a field sensor and a reference sensor. So R goes with reference. There we go. And the Ethernet connection is on the opposite side. You may need to come around here to see that. This body will vibrate during the course of data collection, and you could have this thing vibrate loose. I like to set the chamber in the holder such that this dot is facing upward. That's not necessary, but it's a nice landmark, a reference point to use. It's my preference. And this ring slightly beyond the leading edge of the holder. This allows the placement of the alignment cap. If the alignment cap comes to this ring, if the ring is too far back, you won't be able to get the alignment cap all the way on. So you want to make sure that ring is just past this edge. Snug it up with this knob, and you'll notice this is a dovetail fit underneath, and it's adjustable by this screw, which moves that foot back and forth. You want to back it all the way out, and then you want to place this on that holder. Once it's in place, you want to snug it with this knob at the back, just like so. So this is our reference probe holder. So you can do this a couple of different ways. I'm going to go ahead and put the detector on here and then place the detector and holder both onto the tank after the fact. You can use the holder on the end, but I find that it's a little less efficient. I simply slide the detector through the holder again until you're at the very end, just past, you want this ring just past the end of the tube. When you have it there, you simply tighten up that screw. Just snug, finger tight, not very tight. just enough so that it won't come in or out. And I've got this thumb screw backed out all the way, and it fits on right here on the end of the tank rail. So you simply slide it on, and I'm going to attach it by snugging up this thumb screw from underneath. At this point, the ball joint is still loose. So I usually rotate this around to an area where it's less likely to get hit, and I tighten the black knob snug and leave it like this until I've got water in the tank and I'm ready to move it into the field at the very last. And this is just a threaded connector. Place them into each other. You don't want the weight of this thing pulling the cable down while you're trying to scan, all right? You don't want that. So put slack up in the tank. So pull it back, open it up, slide the cable in, and then you simply push on that until it clicks. And it's ready. We've got all of our cables connected. Hand pendant, power communication, signal cables, ready to power on. The power on switch is located on the back of the chassis. It's immediately adjacent to the power cable. It's just a simple switch. As soon as you flip it, you'll notice some LEDs light up inside here. One important thing to note, there will be a red LED that lights and begins to blink. That does not mean there's an error, even though it says that that's an error indicator. What it really means is that it's in a warm-up cycle. That LED will go away all on its own in about 20 minutes. We need to get the rails out of the way so we can see the bottom of the tank clearly. And you've got a joystick method here for operating the rails. You'll notice the lock icon is lit. And the way you unlock that is there's a little button on the end here, inside, kind of hidden. You have to press it. And as soon as you do, the lock icon goes away. Now you have movement of the rails by moving this, by using the joystick. So you move those out of the way, and that facilitates a clear view now of the bottom of the tank. You'll notice right now the crosshairs are here in the tank, and the shadow is like over here. And the reason I'm doing it that way is I want to follow this, I want to align this crosshair up first and then move the tank that direction until that shadow intercepts this line. That's pretty close. And it's close enough. When we did that alignment, we got the crosshairs close, but not perfect. And then we lock the brakes down, so the lift table is not going to move now. For final alignment, while the tank's still empty of water, I'll turn the lights back off and then just physically shift the tank until I get it exactly where I want it. So there are the crosshairs that are projected by the light of the accelerator head onto the bottom of the scanning tank. We're looking for the shadow of the crosshair to fall directly on top of the etched crosshair. Once you're there, you're ready to put water in. The objective of this procedure is to level the rails with the water surface. We're going to start with that. We've already placed our CC13 ion chamber in the holder. We've got it approximately at the water surface. We're going to use the alignment cap to determine the correct depth in the water, and then we're going to move it around in a series of positions on the surface to establish levelity. Okay? So the first thing we're going to do is, after having the alignment cap placed, we're going to rotate it so that the etched lines on the end of the cap are at roughly 45 degrees, and then move it up and down in the water until the V made by the 45 etched lines just intercepts the water surface. And the way to tell that is to look at the end of it and rotate the alignment cap until you have a nice 45 angle. So we go to our pre-saved positions. I drive to that corner first and I watch it from underneath here. It should be nice and smooth all the way across. And then once it's at that position, then I go back over here, one button click, and then I go to that one at the end. Like I said, a little bit of practice, and that takes about a minute. You can do it really fast once you get used to that procedure. Now this first button that looks like a bullseye down in this corner.
Like a target.
Like a target, yeah. Press that button.
To go to the ISO center.
Yes. So tell it to go to ISO center. You remember how?
This?
Yeah, that one.
Okay.
And then the green arrow.
Go. Huh?
Yep. And it did it. It went back.
Okay.
Okay. Doesn't matter where, just a little bit.
So
And then you select that one, and the green arrow means go, and it should return back to where it saved that initial. If we need to go up or down, yeah, please, thank you. You guys have to from the, it's easier to see from this end than it is from the side, but it's hard to adjust it while you're looking. I want you to change the speed just to demonstrate that we can do that. So go ahead and hit continue and get it started. And then wait until it gets up about, wait till it gets about 25%. Okay. Now what I want you to do is press your mouse, drag it over till it says 2 or 20, and then you'll notice it hasn't changed speed yet. It's still doing the same thing. But as soon as you release, look how fast it's scanning.
Okay.
Yeah. For Eclipse, you have to measure every one of those.
IBA software calculator, forms like that.